Hello, everyone. This is part 5 of season 2 Keio ICU Linguistic Colloquium series. And today we are going to have Shigeto Kawahara from Keio University presenting his work on Pokémonastics and what we are doing and why we are doing it. Please go ahead. Yeah.
Thank you, Seunghun. All right. So I'm going to talk about Pokémonastics, what we are doing, and why we are doing it. Before we proceed, let me make it clear that Professor E and I are really hoping that the videos that we are creating from the Keio ICU-LINC series are useful for teaching and learning resources. So that's why I'm contributing one more video to this series. Second, due to copyright issues, the pictures of Pokemon characters and other characters are those that are drawn by me with the help of my daughter. And so please go ahead and Google to find real pictures if you want to have fun. Finally, this talk contains a lot of selfish promotions of my work, and all the papers can be downloaded from my website here. The URL is given here. Okay. So starting with general introduction, what is Pokémonastics? Pokémonastics is the studies of sound symbolism using Pokemon names. And me and a student of mine, who is now a grown-up researcher, Gakuji started it. And the name Pokémonastics is due to Stephanie Shih at USC. And today I'm going to talk about its history, research strength, and an overview. All right. So let's start with the question of what is sound symbolism? One perennial question in linguistics, philosophy, psychology, and cognitive science is this question. Do sounds have meanings? Or are sound meanings correspondences completely arbitrary? Well, there are basically two opposing views of this question. Saussure, who founded the modern linguistics, and many theories which followed him, including generative linguistics, say, nay, not really. The sound meaning correspondences are arbitrary, in principle at least. Other people, on the other hand, embrace sound symbolism, saying that sounds and meanings have systematic relationships. And this view actually goes back to Socrates. And it seems that many contemporary cognitive linguists agree with this view. So at least there are some correspondence between sounds and meanings. All right, let's look at some examples from Pokemon. Even if you don't know Pokemon, or it's better if you don't know Pokemon, let's suppose that there are two characters like these two, and their names are P or Groudon. Can you make a guess which one is P and which one is Groudon? I guess probably you can. This looks like P and this looks like Groudon. All right. Here's another example. Here's a beloved Pokemon character Pikachu and its relative Raichu and Pichu. So we have these three characters. And if you're asked which one is Pichu, which one is Pikachu, and which one is Raichu, then you can probably make a guess that this little one is Pichu, the one in the middle is Pikachu, and the biggest one is Raichu. So an emerging observation is this. We can to some extent guess which name is best for which character. And this result, or observation, or pattern, is unexpected if the sound meaning correspondence are completely arbitrary. Okay. All right, so this is the whole idea. There seems to be some sound symbolic patterns in the names of Pokemon characters. Let's explore it. Before we delve into what we are actually doing, let me talk a little bit about its history, or how it came about. The very general background of my teaching is this. Introductory classes to phonetics can be boring, or better put, challenging. Students have to memorize all these concepts like place of articulation, manner of articulation, voicing, obstruents, sonorants, aerodynamics, acoustics. And students often wonder, what's the benefit of these analytical tools? And my experience is that many students are also challenged by acoustics because it required some understanding of mathematics and physics, like trigonometry and log transformation, you name it. All right, so I wanted to lower the boundary of these students as much as possible. One strategy that I came up with is to start the phonetics class with sound symbolism. And actually, sound symbolism can make intro to phonetics really interesting. So this is an example from a very popular TV series, especially for girls, called Precure. I think in English it's called Glittery Force. Okay. Anyway, I was playing with my then 4-year-old, and this is Fresh Precure series. And they have 4 Precure fighters in that series. One is Passion, another is Pine, another one is Peach, and another was Berry. Okay. And if you are a linguist, you would immediately recognize that all of the names start with a bilabial plosive, B or P. This was like a revelation moment. Oh my god, precure names start with a labial consonant. And I looked at another series, and this is Mahotsukai Precure, Magical Precure. She is Cure Magical, Cure Miracle, Cure Felice. So they start with M, or bilabial fricative. So all these 7 characters start with a bilabial consonant. So I did some statistical study, and indeed, bilabial consonants are overly presented in the precure names compared to names in other genres. Okay, and through this, students can learn what it means to be a bilabial name. Okay, so this is now how I start my phonetics class, which I think is working okay. And in 2017, I taught a 4-day intensive class, and the Pokémonastics really started with this class. So in day 1, I used sound symbolism to teach basic concepts in phonetics. And in day 2, a then PhD student, Gakuji Kumagai, came back to me with some ideas about potential sound symbolic patterns in Pokemon names. And in day 3, another graduate student, Atsushi Noto, found an online dataset for all the Pokemon characters, and including their attributes like weight and height. And he was an Excel wizard, so he coded all the linguistic characters of their names. And we were going to do some practice with statistical analysis and data exploration. So we figured, why not use the Pokemon data? And that's how we started the actual analysis of Pokemon names. All right. So what was Gakuji's observation that he brought on the second day of that intensive lecture? A really apt example comes from this pair. So a Pokemon character undergoes evolution at most twice, and they are assigned a new name. So there's a character called Nyoromo, and when it evolves into Nyorozo. And notice that it acquires a voiced obstruent here. And when Nyorozo evolves into Nyorobon, then it acquires an extra molar here. So there are 2 emerging observations. One is that evolved characters are more likely to contain voiced obstruents. And second, as Pokemon characters evolve, their names tend to get longer. So this is this pseudo suffix is doing. Okay. All right. Here's another interesting pattern. So in some cases, some Pokemon characters are introduced later as pre-evolution characters of already existing character. To take an example, there used to be Pikachu only, but Pichu was introduced as a pre-evolution character of Pikachu. So in the Pokemon world, they truncated this ka to express the fact that it's pre-evolution. So from the phonological perspective, this is almost like a productive phonological pattern. It's not just about statistic generalization, but when you come up with new Pokemon names, it seems as if designers are making use of these properties. Okay. All right. So we are observing these two sound symbolic patterns, and they in fact have they seem okay. Take a deep breath. These principles seem to be independently motivated elsewhere, at least in Japanese and possibly in other languages as well. So the effects of voiced obstruents were long known, at least in the Japanese literature. Voiced obstruents tend to denote large objects, so it's not mysterious that these sounds were used to express evolution. The effects of name length can arguably be attributed to what's known as the iconicity of quantity. To put it simply, the longer, the larger, or the longer, the stronger. Okay, so we did some correlation analysis. Here on the x-axis, we plot evolution levels. -1 is a baby Pokemon. Those are characters that are introduced as pre-evolution version of the Pokemon characters. And 0 means that no evolution, and Pokemons can evolve twice. And if we plot the number of voiced obstruents, it increases as the evolution level goes up. The same for the number of moras, or the name length. Okay, so we wrote up this initial observation as a paper in 2017 and put it on LinkBuzz. That's a preprint server for linguistic papers. It took some time to get published, but it eventually was published in Phonetica in 2018. And when we look back, the paper was very simple. It just observed that both name length and the number of voiced obstruents affect the size, weight, strength, evolution levels of the Japanese Pokemon characters. But when the manuscript version already caught attention of various people, both within the scholarly community and those outside of it. And already in May 2018, we had an international conference on Pokémonastics. So the manuscript version triggered interest in other scholars to look at Pokemon patterns in other languages. So Stephanie Shih was examining English names, Dasha Kavitskaya was analyzing Russian names, Rebecca Starr was analyzing Chinese names. So this was a pretty good conference. It also caught attention from some popular media. Wired is like a business article, and they wrote an article about it. Keio University newspaper, kindly wrote an article about it, about what their teacher is doing, appeared in some pop science magazines and radio shows. It also appeared in Japanese version of Reddit, Ni-chan. Okay, what we have found. So I would like to talk a little bit more about what we did with Pokémonastic research after Kawahara et al.'s paper. Before we do that, let me review some advantages of Pokémonastics. So there are, I think, 3 distinctive advantages. The first is that we can do quantitative analysis in the Pokemon universe because there are now plenty of Pokemon characters, now more than 800, I believe. Okay, and Pokemon have various attributes like weight, height, evolution levels, strength, type. And this aspect allows us to address the question of what semantic dimension can be symbolically represented. So this is one of the topics that's actively studied in the sound symbolism research. Finally, this is due to Stephanie Shih, but the set of denotations is fixed across all the language in the Pokemon universe, but this is not necessarily the case in natural languages. So let me illustrate the third point with an actual example. Okay. Here's a rather famous example, but English has a word water, but Japanese does not have a word that corresponds to water. We have to distinguish whether water is cold, in which case it's mizu, or hot, in which case it's oyu. So Japanese makes a finer distinction than English. On the other hand, Japanese has just one verb for crying, and it doesn't distinguish crying and moaning, for example. These are just examples showing that languages differ in terms of what they name. And this becomes a challenge when you study basic vocabularies in terms of sound symbolic research across languages. Johansson et al. In Linguistic Typology presents a rather impressive coverage of comparing basic vocabularies in different languages. But they did face this challenge, and this is telling, so let me quote this. They say, for example, when concepts are found to have multiple forms, gender inflections, only the unmarked form was selected to ensure compatibility across languages, as long as relevant information about the meaning was provided through the lexical entries or grammatical descriptions, that is, in the singular nominative for accusative systems, in the singular absolutive for ergative systems, and so forth. In many languages, the same concept can have a number of different roots or versions, which makes it difficult to know which form of a group of words is the unmarked one. Likewise, throughout languages, most concepts also have several synonyms. Therefore, all phonemes from all forms in this case are combined into a single string rather than selecting only one of the forms to represent the concept in question. For example, the three English forms of the third person singular personal pronouns, he, she, it, were analyzed as a single word with 6 phonemes. So they had to pretend as if he, she, it is a one word. I am not saying that this is like a devastating problem, but this is a challenge, and it does increase so-called researchers' degrees of freedom in terms of which lexical items to choose and stuff. Okay. On the other hand, in the Pokemon world, this problem does not arise because Pokemons exist independent of each language. Okay, I think this is a very important advantage of using Pokemon names. Okay, there are other advantages. Mostly it's fun, students like it, and more importantly, students can find their own topics. To be honest, I barely knew anything about Pokemon when it started, and when Pokémonastic project started. So this naturally led to some student-driven follow-up studies. Some examples I'm going to talk about later. And then this is how now the Pokemon project has developed. Sorry that this is in Japanese, but you can see that it has developed into many papers, some by me, some by my students, some by somebody who I totally do not know. Okay. So it developed into 5 directions. Recall that the original study was a corpus study of Japanese, and application to teaching I've already implied, and I want to talk about the rest of the points: experimental verifications, extensions to studies of other languages, new analysis of types, and bridging studies of sound symbolism research with theoretical phonology. Okay, starting with experimental verifications. So if you are a phonologist or linguist, if you find a particular pattern in a corpus, natural question that arises productivity. does the pattern apply with new words, new pictures, new objects? So I found a artist online who drew original Pokemon characters. So these are Pokemon characters, but they're not actual Pokemon characters. This is what the artist drew. And using these pictures, we did some illustration studies as well as forced choice tasks to explore whether what we found in the corpus apply in nonce words or new names with new pictures. This is an excerpt from the results in a paper that's published in Journal of Japanese Linguistics 2019. For example, we presented a pair like Mureya and Zuhemi. Notice that Zuhemi starts with a voiced obstruent. And we asked them which one is better for a post-evolution character. And about like 70% of the time, people found Zuhemi to be better for the post-evolution character. So this result seems to show that the connection between a voiced obstruent and evolution is productive. Okay, and I did many kinds of experiments of this sort. And on this note, I'd like to highlight this interesting point. I use SurveyMonkey for online experimentation. And SurveyMonkey, every morning, it sends you how many participants you get the previous day. And one morning, they told me that I got responses from more than 800 people. And I thought that this was a mistake, this some kind of error. But when I logged in and looked at the free comments, they said that, hey, there was this Pokemon Fun website and your experiment is being advertised, and I came from that. So actually more than 800 people finished my experiment over a single night. And since then, I'm using this website to get participants for the Pokémonastic experiments, at least for Japanese. So this is another advantage. How, it's not easy to find 800 participants who are eager to do this for free. Anyway, moving on to the next point. Extensions to other languages. This is mostly due to, thanks to Stephanie Shih and her colleagues. So she and her colleagues, including myself, looked at different languages like Japanese, English, Mandarin, Cantonese, Korean, and Russian, and look at various Pokemon attributes. And did a whole extensive cross-linguistic survey of what sound symbolic patterns emerge in their respective Pokemon lexicon. And we found different patterns, so it's not like everything is universal. But one thing that I would like to highlight is that this stage or evolution levels, they, in all the languages, the longer the names, the more evolved it is. So there's a correlation between evolution levels and name length. The counting unit differs depending on which language you are talking about. English seems to use segments as a measure of name length. Japanese uses moras. Mandarin uses syllables. But this general pattern seems to hold in all these languages, which I find to be very interesting. Okay. Also, I got an email from the outside, from the opposite side of the globe, Brazil, Mahayana Godoy. And she said she's very interested in doing a new experiment in Brazilian Portuguese. In Brazilian Portuguese, Pokemon names are all English. So there's no Portuguese Pokemon names. So she figured that, if we don't have them, why not ask people to come up with them? So we did an illustration experiment with native speakers of Brazilian Portuguese, and we found effects of voicing and vowel height on the judgment of evolution status. experimental paradigm gets refined and refined. And in one of the new experiments, the most latest experiments, we varied 3 phonological dimensions. This is in collaboration with Keio and Brace at UCLA. It's appearing in LabFont. We varied name length, vowel quality, and consonant voicing. And we see that longer names, and the y-axis is the post-evolution responses. So long names tend to be judged as more evolved than short names. Names with a tend to be judged to be post-evolution more often than names with a. And names with voiced consonants are more likely to be associated post-evolution characters than voiceless consonants. Okay. And interestingly, these seem to be cumulative and linearly so. Okay. This was clear in the Stephanie Shih et al.'s work, but the longer the stronger principle, or the iconicity of quantity, seems to be a very robust tendency that holds across all the languages studied so far. And so there are 3 languages that are kind of extensively studied: English, Japanese, and Brazilian Portuguese. And this principle, the longer the stronger, seems to hold in all the languages, both in the corpus and the experiments. The effects of voiced obstinance are also tangible in all these languages, but the effects are more robust in Japanese than English and Brazilian Portuguese. This also I find very interesting. So the effect is there, but the strength may differ across languages. This is digressing a little bit, but I've also studied the so-called Bouba-Kiki effect. It's a very famous effect in the psychology literature. So if you are given 2 pictures, like a roundish picture like this, and a spiky picture like that, and you're told that these are either Bouba or Kiki, many people associate this with Bouba and associate this with Kiki. So I figured, why not use Pokemon to explore the Bouba-Kiki effect? We have round Pokemon and angular Pokemon, and I explored which phonological dimensions affect this round angular judgment. So I varied place of articulation and consonant voicing and vowel backness. There's work by Donofrio in language and speech, which I should have had on the slide. My apologies. But anyway, it's a direct follow-up of Donofrio's work. We can see that labial and the y-axis is round responses. So labial names were more likely to be round than alveolars and velars. Voiced consonants were generally judged to be more round than voiceless. And back vowels, or probably front rounded vowels, are more likely to be associated with rounded Pokemon than non-rounded. The rounded vowels are more likely to be associated with round Pokemons than front names. Okay, and again, the interaction of these phonological factors seem to be cumulative. And if you're interested in theoretical implications of this cumulativity as well as linearity, please take a look at the recent paper by Kawahara and Breeze. Okay. Now, type. So right after I circulated the manuscript, students from a university in Tokyo came up to us and asked, what about types? So I said, well, I don't know much about types. Why don't you investigate it? And they actually formed the group and did some study. So they looked at the names of villainous characters and non-villainous characters, and they looked at the distribution of voiced consonants and voiceless consonants and see if there was a difference. And as you can see from this chart, villainous characters are more likely to contain voiced obstruents than non-villainous characters, 46% versus 37%. And they wrote up a paper with their teacher. So it's now available in Review of Cognitive Linguistics as Uno et al. They looked at another type effect. So they compared dark type Pokemon and fairy type Pokemon, and they looked at the distribution of bilabial consonants. So this is the reminiscent of the precure effect that I discussed at the beginning of the talk. So the fairy type Pokemon was far more likely to contain bilabial consonants than dark type Pokemon. So what have we learned so far about types? It seems like villainous characters are associated with voiced obstruents. Fairy type characters are associated with labial consonants. And another thing that we have explored is flying type characters are associated with sibilants like s and sh. And interestingly, this intuition goes back to Socrates and the Upanishads. So, these ancient writers already had this intuition about the relationship between sibilants and flying, and we are testing their intuition using Pokemon. Kind of find that exciting. And we have experimentally studied these patterns with Japanese speakers, English speakers, and speakers of Brazilian Portuguese. There's an interesting hypothesis, which is tentative but also intriguing, that's emerging. So Shih et al.'s work found that Pokemon genders are not very clearly expressed sound symbolically. So Pokemon have genders, but their names are not correlate with their genders. In a real world, on the other hand, gender is one semantic dimension that is very clearly expressed sound symbolically. There's a recent overview article by Sidhu and Pexman, which I really recommend. So here's the point. In the real world, we express gender in terms of sound symbolism. In the Pokemon world, we don't. We instead express like types and strength. And we can interpret it to mean that in the Pokemon world, what's important is not really gender because their aim is to fight with other Pokemons. And what's important for their survival is how strong they are and which type they belong to, because some type has advantage over other types. So maybe we can formulate this general hypothesis that sound symbolism is used to express properties that are important for their survival. Okay. Here's an example from of another student-driven project. This is Michinari Suzuki from ICU. He asked, what about moves? And I was like, what are moves? Moves, Pokemon fights, and they use moves, like karate moves. Okay. And he did a corpus study and found some effects of voiced obstruents and molar counts, which are not super clear. So we did a judgment study. We varied more length from 2 to 7, and we manipulated the presence of voiced obstruent, no voiced obstruent, and yes voiced obstruent. And we found this nice correlation between molar counts and attacked values, and names with voiced obstruents were more likely to be judged to be stronger than voiceless obstruents. Okay, so it found some interesting effects, and it appeared in working papers. Okay, this itself, well, student-driven project, I think this result is nice, but this actually allowed me to bridge research on sound symbolism and formal generative phonology. So I'm very grateful to Michinari for doing this project with me. So let me expand on this point now. Some people get surprised, but I'm actually a generative phonologist by training, and I used to be a hardcore optimality theory practitioner as a graduate student. And if you ask me if I'm a generative phonologist, I'll probably say yes, partially at least. But the fact is, the generative linguists barely pay any attention to sound symbolism. So here's a telling quote from an old paper by John McCarthy. I'm not implying anything negative. I'm just presenting this quote because this is a very representative. So McCarthy analyzes lots of phonological and morphological patterns in onomatopoetic expressions. And he says, many of the examples that I discuss here may be subsumed under the general designation of sound symbolism because they make phonetic distinctions that sound in an essentially iconic relationship with their meaning. My concern here is entirely with the formal properties of these systems. And I skip the next sentence and say, thus, I have nothing to say about the issue of iconic versus symbolic meaning. So he's aware that there is sound symbolism involved here, but he's not interested in it. I think this is a typical generative grammarian attitude. Again, I'm not implying anything negative. This is what they do. However, I feel very different. I now believe that formal phonology and research on sound symbolism can and should inform one another. One article that I was really inspired by is this paper by Alderete and Kachetov in Language. And I had an opportunity to think about it and summarize my thoughts and published a paper in Language and Linguistic Compass. And just a little bit of a side story. This paper, one of the papers was rejected by a theory heavy journal, and the editor said, "Hey, we are publishing theoretical linguistic journal. Sound symbolism is not really, interesting." And I was like, "Wait a minute. Sound symbolism can be interesting for theoretical phonology." So I'm actually very grateful to the editor because it allowed me to think through why it's important. Okay. Let me illustrate this with an actual example. So a popular framework that has been around in generative phonology is so-called maximum entropy harmonic grammar, which is also known as multinomial logistic regression. Bruce Hayes has this very nice paper which shows the mathematical properties of this maximum entropy harmonic grammar. So one property is that given a linear scale, consider this as a violation scale, how many times a candidate violates a constraint, and y-axis is the probability of the candidate that appears this constraint, that violates this constraint appearing. So it turns this linear scale into a sigmoidal scale, that is S-shaped scale. So this is one property of maxent grammar. It converts a linear scale to an S-shaped curve. And when another constraint is relevant, it can shift this curve. So it creates two sigmoid curves. And together, they look like a wug, our beloved animal in phonological and linguistic research. So Hayes asks, do we observe these wug-shaped curves in phonology, syntax, other linguistic patterns? Now, I was really inspired, and during the COVID crisis, let's do something fun. And I did this experiment where I varied the number of Murakans name length and see if that would result in an S-curve. And indeed it did. And I also had two conditions, one without a voiced obstruent and one with a voiced obstruent. And there was a shift. So this is indeed a wug-shaped curve in sound symbolism. And I'm very pleased to announce that this has been accepted by Phonology, a very theoretical journal. So finally, theoretical journal agreed that studying sound symbolism from the perspective of theoretical linguistics is interesting. Okay, so to summarize, Pokémonastics can allow for an interesting cross-linguistic comparison of some symbolic patterns. It's fun, and it can attract interest from students and the general public. And this is what I'm most interested in right now. Pokémonastic or research in sound symbolism can potentially make a bridge between sound symbolic research and formal phonology. And what's left to be done? Well, there are many aspects of Pokemons that needs to be explored. There are other languages that can be examined, and we should do more experiments. Thank you very much. That's it.
Thank you. Thank you for the exciting talk. And yeah, we'll stop the recording now.